thing. Have you ever flipped a switch and wondered where that instant light actually comes from? How does electricity just magically appear in our homes? Well, it's not magic. It's some seriously cool science. And today, we're going to break it down. Let's start with the most common method, the generator. Think of it as the powerhouse behind the power. Most power plants, whether they're using coal, nuclear energy, or even water, rely on a simple but powerful duo, a turbine and a generator. Here's the basic idea. You need something to spin a turbine. It could be rushing water from a hydroelectric dam, or pressure steam created by heating water with coal or nuclear reactions, or even strong gusts of wind. This spinning turbine is connected to a generator. It causes massive magnets to rotate around coils of copper wire. This movement excites the tiny particles called electrons inside the copper, forcing them to move. And guess what? The flow of moving electrons is what we call electricity. So, whether it's a massive dam or a towering wind turbine, the core principle is the same. Spin something to make magnets move, and you get electricity. But wait, there's another superstar in the world of electricity, and it doesn't need to spin anything at all. I'm talking about solar power. Solar panels are like silent, sun-powered magic carpets. They use special materials, usually silicon, that have a unique property. When sunlight, which is made of tiny energy packets called photons, hits these panels, it knocks electrons loose from the silicon atoms. These freed electrons are then guided into a path, creating a direct electrical current. No turbines, no steam, no moving parts. Just pure, clean energy straight from the sun. It's an incredibly elegant way to generate power. We briefly mentioned wind before, but let's look a little closer at those giant, graceful wind turbines you see on hills. They are essentially a modern, high-tech version of old-fashioned windmills. But instead of grinding grain, they're generating electricity. The wind pushes against the massive blades, causing them to spin. Just like in a power plant, this spinning motion turns a shaft that's connected to a generator, too. And you know the drill from there. The generator S spinning magnets and copper wires create an electrical current. So, a wind turbine is basically a power plant that uses the air itself as its fuel. Now, I bet you're thinking, this is all great, but it's happening in giant power plants. Can I see this in action? And the answer is yes. You can create your very own mini power source with a simple lemon battery. It's a fun and safe experiment, but make sure to have an adult around to help. Here's what you'll need: a lemon, a copper coin, a zinc-coated or galvanized nail, and a tiny LED light. First, roll the lemon on a table to soften it up and get the juices flowing. Then, carefully push the copper coin into one side of the lemon and the zinc nail into the other. Make sure they don't touch inside the lemon. These two different metals, the copper and the zinc, will react with the acidic lemon juice. This chemical reaction pulls electrons away from the zinc and sends them toward the copper, creating a tiny electrical current. If you attach small wires from the coin and the nail to the legs of your LED, it will light up. You've just made a battery out of a fruit. So, what's the big takeaway from all this? Whether we're talking about a massive nuclear plant, a solar farm stretching for miles, or a humble lemon on your kitchen counter, the fundamental secret to electricity is the same. It's all about getting electrons to move. From the controlled chaos inside a generator to the silent reaction in a solar cell, every light, every phone, every device we use is powered by the directed flow of these invisible, energetic particles. It's a universe of power, all sparked by a simple movement. Thanks for nerding out with me today. If you enjoyed this journey into the world of electricity, don't forget to hit that like button and subscribe for more deep dives into how our world works. See you in the next video.